how to do investigations. I'm going to use this experiment as my my example to make up an experiment on temperature and water evaporation. Okay, so the thing you need to do with all investigations is get a good title. You don't want it to be more than a line long, but you do want it to explain what's going to happen in the investigation. Investigation to find out how temperature affects the rate of evaporation is good. Getting water into the air, no, that's less marks, because you haven't said how it's going to get into the air and what you're going to vary. You must say what you're going to vary, in this case the temperature, and say how it's going into the air. Make a hypothesis with a scientific explanation. Don't just say, oh, I reckon it's going to be more if you make it hotter. No. I predict, that's a good way of doing a hypothesis, that evaporation will be faster at higher temperatures. So mention the thing that you're going to change. All experiments have to have a variable, something that varies, something that you can make it vary. In this case, it's going to be, oh, I can control the temperature. And then something that you can measure. In this case, it's going to be the mass of water, because more water molecules will have enough energy to escape the liquid surface. So your hypothesis can be based on knowledge you can glean from the internet and stuff. Most science experiments that you can do have already been done by somebody, and you're just checking them out. But you still have to write a hypothesis. Why do you write a hypothesis? Even if we know pretty much what the answer is, you write a hypothesis to get the marks. Okay, that one's good. I think the air will be more humid faster when hot because the H2O molecules will have more kinetic energy is less marks. You've got some scientific words in there like kinetic energy and stuff, but it just is a bit chitty chatty. It doesn't sound scientific. Select suitable apparatus. Yeah. So when you're saying, oh, I need this apparatus, don't say, I need a beaker, I need a measuring cylinder. You have to say which one. 100 centimeter cube measuring cylinder to measure the amount of water is good. 100 centimeter cubed beaker to get the volume of water is less marks. Yeah. Well, measuring cylinder is much more accurate than a beaker, for a start. Beakers are less accurate than measuring cylinders. I will use a digital balance to weigh the amount of water before and after the experiment is more marks, because balances are more accurate than measuring cylinders. Ah, yeah, that's good. Devise a fair test. Okay, now you have to write down exactly what you're gonna do so that anybody following your experiment, doing your experiment, can't get it wrong. So avoid the word it, because people don't know which it you're talking about. It's indefinite article. Be definite with all your articles. I will put 100 centimeters cubed of water at 30 degrees C in a cup, and 20 centimeters cubed of water at 31 degrees C in a bowl. Oh, well, no, you don't put one in a cup and one in a bowl. They've got to be in the same piece of apparatus, and the only thing that changes is the temperature. You don't want different volumes of water. It has to be the same volume. Only one thing is varied in an experiment. Because the bowl has more surface area than a cup, well, that's going to lose your mark. And the volumes are not the same. You have to write down what volume you're going to use. Now, that does mean sometimes like doing some research, because you can't just say, oh, I'm going to use 100 litres and then find out, oh, that's a bit too much to do an experiment. And the temperatures will quickly revert to room temperature. Oh yeah, 31, 30. They are hardly different at all. You want decent different temperatures so that you can put it on a graph. And just 2? And you'll get only 2 results. Yeah, no, you need at least 6. You will need at least 6 results to make a graph. And the 2 temperatures are too close. It is best to have a wide range as possible. Yeah, so 100 degrees C is possible. I'd go probably for 90 degrees C, then 80, then 70, then 60, then 50, then 40, then 30. then 20, then 10, then 0. 0 is a nice easy one to keep it at 0 because you put some ice in the water. 100 grams of water is placed in a 100 centimeter cube beaker in water baths kept at, oh yeah, water baths are a good idea. Use electricity to keep it at the temperature you specify and use a thermometer to make sure the water bath is working. 0, 10, 20, 30, 40, 50, 60, 70, 80. No, you don't need a water bath for that, but really, if you're going to use a water bath for all of them. If you can find a water bath that does all of those. Each experiment is repeated 3 times and the results average to be improve reliability. Yes, because people make mistakes. And so if you mess up the 40 degrees C experiment, you want to know that it's messed up by doing it 2 more times, giving you 3 results. If one of the results is way different from the other 2, you know to leave it out of your results. Well, you do mention it in your experiment to get the marks. You get marks for sensibly getting rid of errored results. And you just go, oh, it's experimental error, I don't know why it went wrong. You can't have 2 that are like this and then one's weird. Because humans make mistakes. Collected results. An hour later, outside of the beakers will be wiped dry and then weighed to determine the rate of loss by evaporation. Is good. I weigh the water, is less marks. Safety. I'll use a heat-proof gloves and great care to keep the water samples above 20 degrees C over the bench. Yes, because you don't want like 80 degrees C water falling onto people when they knock the bench. I will wear goggles, is less marks. I mean, everybody, all experiments, most experiments need goggles. So you got to be interesting with your safety rules. Errors. I will press the balances tare button before each weight measurement to make sure it is reading 0. Yeah, most measuring machines have some kind of tare. Okay, rulers don't. But measuring machines, electrical ones, they have a button to press that goes 0 before you start doing things each time. I will be aware that rulers have 5mm at the start. That makes a 0 error, is less marks for this experiment because there's no rulers in the experiment I'm telling you about. That would get you a mark in other experiments. If you need a ruler, mention this. Tables. A table of results with the temperature in the first column is good. The variable you control is called the independent variable. It varies. Yeah, you can vary the temperature. The second column, result, depends on your measurements. Yeah, you find out how much water was lost. It is the dependent. Yeah, it depends on what you do in your experiment. All other variables like the size of the beakers, the thermometer used, and you could use several thermometers all of the same type. That would be accurate enough, but using one each time would be more accurate, just in case the thermometers are not made carefully enough or you pick a duff one. The temperature of the room are kept constant to keep the experiment fair. Well, yeah, you're not going to change rooms. You're not going to do it sunny days one day and middle of winter the next. It's going to cause trouble. Draw a graph. Yeah, marks. The variable you are in charge of is the independent variable written on the x-axis. In this case, the x-axis is the temperature. Yes. X-axis is the one. Hold on, that was the one that should be evenly spaced. That should be the temperature. That's the dependent. No, the independent one. Oh, God. Yes, and the y-axis is the amount of water. Conclusion and evaluation. Well, then you've got to look at your results and go, my hypothesis was right, and then restate the hypothesis again, changing the word order a bit to make it sound like a this is finished thing rather than this is now a question. On the back of this page, write the title hypothesis. The hypothesis, the apparatus, method, results, safety, errors, table for results, graph, conclusion, and evaluation for an experiment on the effects of wind on the evaporation of water. Cool, yeah, you can write them down there. I'll mark them for you. Go!